It's 1903. A worker in a cave in Cheddar Gorge, England, hits something in the dirt. A human skull, and under it almost a whole skeleton. The most complete ancient skeleton ever found in British soil. For a century he sat in a museum, everyone assuming this ancient Englishman looked, well, English. Then in 2018, London's Natural History Museum pulled DNA from his tooth, and the result went around the world. Britain's first modern human had dark, near-black skin and bright blue eyes. So here's the question that should nag you. If the first Englishman was black, when did the rest of the planet get its colors? Let's start at the beginning, the real beginning. About 300,000 years ago, when the first Homo sapiens showed up in Africa, they all had dark skin. Not most of them, not the majority, all of them. The oldest fossils of our species come from a site called Jebel Irhoud in Morocco, over 315,000 years old. Fossils don't preserve skin, obviously. Bone and teeth don't come in color. But the biology, the ecology of Africa, and the genetics of living people all point to the exact same answer. Those first humans, standing under a sun that hammers straight down, were loaded with melanin. And here's why that mattered so much. Melanin is the dark pigment your skin makes, and its day job is blocking ultraviolet radiation. UV is invisible, but it is not harmless. It pours off the sun, sinks into your cells, and starts breaking things, snapping chemical bonds, damaging your DNA. Let that damage pile up in the wrong spot for years, and it becomes skin cancer. So dark skin is basically built-in sunscreen. SPF you're born wearing, no reapplying every 2 hours, no greasy hands. But cancer probably wasn't even the main event. UV does something sneakier. It destroys folate. Folate is a B vitamin, and it is absolutely critical during pregnancy. It's what protects the neural tube of a developing baby, the structure that becomes the brain and spine. A pale, pregnant woman standing under the equatorial sun would have her folate wrecked before it ever reached the baby. Those pregnancies often failed. Her genes didn't get passed on. Generation after generation, that brutal filter quietly favored more melanin. In Africa, for hundreds of thousands of years, dark skin wasn't a style choice. It was the difference between a pregnancy that worked and a loss no one could explain. And then humans started leaving Africa. This is where the story of skin color gets complicated. Leaving wasn't a single event. It was waves over tens of thousands of years, groups pushing north and east across Arabia into Eurasia, some coming back, some vanishing along the way. And as they climbed in latitude, the environment quietly changed the rules on them. The sun got weaker. The farther you go from the equator, the less UV reaches the ground. In a northern European winter, the sun sits so low that barely any UV punches through the atmosphere at all. And now the whole game flips. Suddenly, the danger wasn't too much UV, it was too little. Because you need some sun hitting your skin to make vitamin D, the stuff that lets you absorb calcium, build strong bone, and run your immune system. Without it, bones bend, kids stop growing right, and disease walks in. Rickets, repeat infections, dead children. So here's the irony of evolution. Dark skin, which was a lifesaver at the equator, became a liability in the frozen north. It blocked so much UV that the little sunlight up there couldn't make enough vitamin D. Whoever had slightly lighter skin caught those weak northern rays better, made more vitamin D, raised healthier kids, and passed those genes on, which means light skin is not an upgrade. It's not more advanced or more modern. It's just a local adaptation to a specific problem. Drop that same pale skin back at the equator and it's a disadvantage instantly. Skin color isn't a ranking. It's an address. It tells you where your ancestors stood, nothing more. Now some of you are thinking, sure, but Europe has basically always been white, right? Fair guess, and completely wrong. In a Spanish cave called La Braña, researchers found a hunter-gatherer who lived 7,000 years ago. In 2014, the journal Nature published his DNA, and the answer was the same as Cheddar Man, dark skin, blue eyes. A European, living where Spain is now, still carrying his African ancestors' pigment. The blue eyes had already arrived. The pale skin had not. That combination almost nobody sees today, dark skin, light eyes, was just normal in Europe for thousands of years. So what changed? Why did Europe become the Europe you picture? The turn came from a single migration at a specific moment around 9,000 years ago. Farmers living in what's now Turkey and the Middle East began spreading across Europe, bringing a brand new invention with them, agriculture. Wheat, sheep, staying in one place. And in their DNA, they carried a variant of a gene called SLC24A5, one that dials melanin down. The local hunter-gatherers simply didn't have it. As the farmers moved in and mixed with the locals, that pale skin variant spread with them, And a second gene, SLC45A2, swept the continent even later. The white Europe in your history textbook is, on an evolutionary scale, shockingly recent. The last 6,000 years, give or take. And there's a twist in how fast it happened. Those hunter-gatherers ate a lot of meat, fish, and liver, food packed with vitamin D. When they became farmers, the menu changed, more grain, less liver. Their dietary vitamin D dropped, so the pressure to make it in the skin instead cranked up even harder, and pale skin became an even bigger advantage. Which means farming itself may have sped up the whitening of Europe. Changing the food changed the color of a continent. They really don't teach you that one in school. And while all this was happening in Europe, something similar was unfolding on the far side of the world through a completely different door. East Asian populations also evolved lighter skin. But the main gene behind it isn't SLC24A5, it's a different one, in the MFSD12 region. Two groups of humans, same problem, similar solution, totally separate genetic roads. Biology has a name for that: convergent evolution. Nature inventing the same answer twice, on purpose, without a plan. And if you still want a clean rule, far from the equator equals pale skin, one group breaks it completely. The Inuit, living in the Arctic across Alaska, Canada, and Greenland, are among the farthest people from the equator on Earth. By latitude alone, they should be some of the palest humans alive. They're not. Their skin runs medium to dark. Why? The food. They eat fatty fish, seal, whale, and marine liver in enormous amounts, a diet so rich in vitamin D that they never had to depend on their skin to make it. The problem was already solved on the plate, so skin color isn't just latitude. It's latitude, plus diet, plus migration, plus time, all pulling at once. Which brings us to the part that makes people uncomfortable. For centuries, the idea that humans come in fixed biological races was used to justify slavery, colonization, and worse. And modern genetics dismantles that idea in a way that's hard to argue with. Skin color is what scientists call a polygenic trait, controlled by more than 100 genes, each adding a little. And those genes do not travel together as a package. In 2017, geneticist Sarah Tishkoff published a study in Science analyzing over 500 Africans and found that many of the gene variants behind both light and dark skin are older than our species, over 300,000 years old. Alleles people think of as European are common across Africa too, and the single most skin color diversity anywhere on Earth is inside Africa. Race, as a fixed biological block, simply doesn't show up in the DNA. So come back with me to that cave in England. Cheddar Man, dug out of the dirt in 1903, sat in a museum for over a century while everyone pictured him looking like a modern Brit. Then his own DNA corrected them in a single test. Dark skin, blue eyes, an ancient Englishman who, if he walked down a London street today, nobody would call English. The story of human skin color isn't a ladder climbing from dark to light, from primitive to civilized. It's a web of migrations, mixtures, sunlight, food, and genetic accidents that, over hundreds of thousands of years, painted the face of every single person alive. Everyone with light skin, anywhere on the planet, descends from people with dark skin. That's not poetry, it's genetics. And that specific shade on the back of your hand, whatever it is, doesn't sort you into any fixed box. It just quietly records where your ancestors stood long enough for the sun and the food to leave a mark. It's an address, not an identity. And that address has moved so many more times than any history book lets on. So if even your skin, the one thing that feels the most permanent, the most just how I am, is really only a passing adaptation, what else that feels fixed is actually just a phase. For more on how the human story really worked, the versions the textbooks skip, subscribe. This is Sketchient, and if you want to know what those same ancient humans looked like before any of this, the people we shared the planet with and lost, watch this next.